above the x-axis. So it looks like this is my feasible set. It's all this stuff down here. If you were to check where all the shadings overlap, it should overlap here. So there's my feasible set. And now that I have my feasible set, we just look for corner points. So where are my corner points? Well, I have one here at the origin. I have one here. I have one here where these two lines intersect. And I have another one here. OK. So now all that remains to do is find the coordinates of all these corner points and then plug them into our objective function here. So let's look for the coordinates of the corner points. So I've left the equations of the red and the purple. So maybe I should mention that this is the red guy, and this is the purple guy, just to keep things straight. We have those equations up there, because we'll need them in a moment. So first, I know one corner point is 0, 0, so that's good. This one I also know, this is the red, the y-intercept of this guy, which is 7. So this is 7, 0, 7. This one, it looks like it's 6, 0, but you know, I'm pretty sloppy at graphing, and I started up here and then kind of just extended the line. But maybe I was bad at that, so maybe we should check just to make sure what the coordinates of this point are. The coordinates of this point are, to make sure that I got this right. So what is this line? This is the intersection of the x-axis with the purple line. So that's really solving the system y equals 0, and the purple line is negative 3/4 x, y equals negative 3/4 x plus 9. So to find this guy on the x-axis, I solved this system, which means I just plug y equals 0 into this equation. So I'm going to do that, and we're going to solve for x, and that'll tell us the x coordinate. So multiply both sides by 4, and maybe negative 4. Okay, get 3x minus 36, and then so that means 3x equals 36. So I guess x equals 12. So this x coordinate, you know, I drew my graph badly, but that's okay. It's not to scale. This is actually 12, 0. 12, 0, according to what I just did here by solving that system. So this should be 12, 0. That was 0, 0, 0, 7. So I know that so far these are 3 of my corner points. Next, I need to find the last corner point. That's the intersection of the red line and the purple line. So again, to do that, I'm going to take the two equations, one for the red line and one for the purple line. And I'm just going to solve this system. So I'm going to substitute y equals negative 1/2 x plus 7 down here for y. So negative 1/2 x plus 7 equals negative 3/4 x plus 9. And now I'm going to solve this for x. So I can multiply both sides by negative 4. I will get 2x minus 28 equals 3x minus 36. Subtract 2x from both sides, add 36 to both sides. I think we're going to get 8. I think we're going to get x is 8. If I do that, x is 8. So the x coordinate of this point should be 8. And then to find the y coordinate, I just substituted in up here. So like y equals negative 1/2 x plus 7. If I put in 8 for x, I'll get negative 1/2 times 8 is negative 4, plus 7 is 3. So I think y is 3. Maybe 8, 3 are the coordinates of that point. Okay. So I have now solved for all the corner points. I have all 4 of them. So now that I have that, the last thing to do is, of course, plug them all into our function and see what our maximum is. Again, this function represents cubic feet of storage space for the amount of cabinets that I buy, which is what we're trying to maximize. So it's good to remember what these things mean. You know, anyway, so I have 0, 7, 0, 0, 12, 0, 8, 3 are my 4 points. So let's plug them into this function here. So if I plug in 0, 7 into 8x plus 12y, that's going to be 0 plus 12 times 7. 12 times 7 is 84. Hopefully I'm doing that right. 84. So I think we ate 84. Yeah, okay, that's right, 84. If I put 0, 0, I'm going to get 0 plus 0, which is 0. So obviously, if I don't buy any cabinets, I don't get any storage space for my files. So that's good that this makes sense. So there's 0, 0. 12, 0 will give me, well, 12 times 8 is 96. 96. And finally, 8 and 3 will give me 8 times 8 is 64. 12 times 3 is 36. So what's 64 plus 36? I believe that's 100. If I'm doing my math right. So out of these, what is the maximum? Well, of course, the biggest number that I wrote down here is 100. So here is our max. Here's our max. Our maximum is 100, and I can get it by purchasing 8 of cabinet X and 3 of cabinet Y. That's the best combination of the two with the amount of money that I have and the amount of floor space that I have available. This is my best option. Okay. So if I buy 8 of cabinet X and 3 of cabinet Y, I will get 100 cubic feet of file storage, and that's the best I can do. Okay. So there we go. That's an entire one of these problems from start to finish. You can see how we basically just put everything together that way I've talked about the past couple of classes. So I'll pause and ask if there are any questions. Okay, I'm going to do one more just for completion's sake. I'm going to do one more. I think this one's easier to write down maybe to state the problem. But it'll be very similar to this one. Just one more of these, and then I'll turn you guys loose. I think I will have said all I need to say about linear programming. Okay. So one more problem. This one's about cake. So let's say you're a bakery and you're producing cake, baking cake at a bakery. We have two different kind of cakes that we're going to consider here. So there's a vanilla cake. And this is going to, if I'm going to make this, it requires 200 grams of flour and 25 grams of fat. So flour and fat, not very nutritious. Next, there's chocolate cake. This requires 100 grams of flour and 50 grams of fat. Okay. Our goal now is to find the maximum number of cakes that we can produce that can be made from 5 kilograms of flour and 1 kilogram of fat. So here's our goal. We have two types of cake. Cakes require flour and fat. And I have 5 kilograms of flour and 1 kilogram of fat on hand. So we're asking what's the maximum number of cakes that I can make. Okay. So again, it's good to look at what our relevant information here is. You know, we're told that a vanilla cake requires 200 grams of flour and 25 grams of fat. Chocolate cake requires 100 grams of flour. This purple marker might be dying on me. And 50 grams of fat. And finally, we're told that in total I have 5 kilograms of flour and 1 kilogram of fat. So the red and the purple are sort of telling me how much of certain things it requires to make vanilla or chocolate cake. These green things are going to give me my constraints, because this is, you know, I only have 5 kilograms of flour. I only have 1 kilogram of fat. I cannot exceed those numbers. So they give me constraints. I'm constrained by those. Okay, so first things first. what are my variables? You should always tell me what the variables are first. But of course, the variables just represent the things that I don't know but would like to know. What do I not know? Well, in some sense, what I don't know is the maximum number of cakes. But maybe more to the heart of the matter is, how many of each type of cake should I make is what I really don't know, right? I don't know how much of each cake to make. And so I'm going to have a variable for vanilla cake and another variable for chocolate cake. And so you guys should always be polite and tell me what your variables are and what they represent. So we'll say X is vanilla, the number of vanilla cakes, and Y is the number of chocolate cakes that I'm going to make. I didn't really do this in the last problem so explicitly because it was kind of obvious because there was cabinet X and cabinet Y. In this case, it's not so obvious. So I'll just be polite and tell you X is vanilla cake, Y is chocolate cake. When you're solving one of these problems and you're writing out your work, which you will have to do on the exam and also on the activities, you should always be nice and tell me exactly what your variables are representing so that I don't have to guess which one you picked for which. You should just tell me. That's the polite thing. I think on web work, it asks you to do that anyway. So just a good thing to be in the practice of, or in the habit of doing. Anyway, I have my variables, one for each type of cake. Next, let's find our objective function. The objective function is the thing that I want to maximize. So what's it say here? We're supposed to find the maximum number of cakes that can be made. So what should my objective function be? Well, it has to represent the number of cakes that I'm making. How many cakes am I making? Well, it depends on how many vanilla cakes I make and how many chocolate cakes I make. But it stands to reason that if I'm making just those two types of cakes, I just need to take the number of vanilla ones that I make and the number of chocolate ones that I make and add them together to get the total number of cakes that I've made. So P for us is just X plus Y. It's just the sum of X and Y. Because this will tell me how many total cakes I have made by just taking the number of vanilla and adding it to the number of chocolate. Okay, so there's our objective function. Okay, now that I have that, let's look for our constraints. Constraints. Again, we'll just write down our implicit ones first so that we don't forget them. So again, we should probably have that X is greater than or equal to 0 and Y is greater than or equal to 0. I can't have a negative number of cakes. That doesn't make any sense. And now I have two other constraints, one for fat and one for flour. I'm limited by the amount of flour I have and the amount of fat I have, so that gives me two more constraints, one for each. So they told us that we have 5 kilograms of flour, and each vanilla cake takes 200 grams of flour, and each chocolate cake takes 100 grams of flour. So we need to be a little careful and note the units that we're using here, right? The vanilla cake takes 200 grams of flour, and chocolate cake takes 100 grams of flour. And in total, how much do I have? I have 5 kilograms of flour. So there's a difference between kilogram and gram, right? Those are just different units. So I better convert between them to make sure that everything I'm writing down makes sense. It doesn't make sense to add kilograms to grams, but it does make sense to add grams to grams. So there's a bit of choice here. I could either convert grams to kilograms or I could convert kilograms to grams. It doesn't actually matter, but once you make a choice, you have to be consistent. The choice that I'm going to make is let's convert kilograms to grams because that just feels more natural to me. And all we need to do is just remember that kilogram is 1,000 grams. So 1 kilogram is 1,000 grams. The prefix kilo means 1,000. So 5 kilograms is 5,000 grams. So when I write my inequality, I have to use the 5,000 instead of 5 because I want everything to be in grams. So that's something to keep your eye out for when you're doing these problems, is to make sure that your units all agree. That's one thing. So, okay, we've made our necessary conversion. So now let's make our constraint. So I'm limited by 5,000 grams of flour.